Pleasure to be here tonight. It's always great to see such a large audience on a Friday night. Reminds me of a trip I made to Ohio. There's an event called Mothapalooza every summer in Ohio, and last summer I took 3 students to Mothapalooza, but on the way we had to stop in Columbus, Ohio, because I had to talk to the Grange Audubon in Columbus, Ohio. And one of the students said, "Can I come to talk with you?" And I said, "Sure." So we get to talk in this room full of people, and he said, "Is this a conference?" And I said, "No, it's just me." He said, "These people are here just to hear you?" I said, "Yeah, I haven't figured that out yet either." But okay, let's get going. What is that beautiful bird? Quetzal. It's a resplendent quetzal. It's an endangered species in the forests of Central America, and it's endangered for one primary reason: it has a very specialized diet. If you don't have fruits of the wild avocado tree, you don't have resplendent quetzals. And unfortunately, we've cut down most of the wild avocado trees. But we want these birds in our future, so we figured out we actually can plant those trees. That's what these young folks are doing right there. Tree's not very big, but it does grow pretty quickly, reaches the age at which it produces those fruits in not too many years, and it's starting to look better for that beautiful bird. That same conservation scenario is repeated time and time again. If you want to save jaguars, you have to have particular species of palm trees. Why palm trees? Because they make palm nuts. And palm nuts happen to be the favorite food of peccaries, which is the favorite food of jaguars. So we're talking about specialization in the natural world, particularly focused on food webs as being the rule, not the exception, and it always starts with plants. Now, a lot of people think that you get all of that specialization in the tropical areas of the world because there is so much of it there, but we actually have a good deal of specialization up here in the temperate zone as well, and some of the most specialized relationships that have ever occurred occur right in our yards. And this is one of them. This is the bola spider. That's a female hanging from a riverbirch leaf in my yard. It's obvious why she's called a bola spider. She doesn't spin a web. She just drops a single strand of silk and puts one sticky glob of glue at the bottom there. Now, she doesn't swing it around her head like a ball, but she does. It looks like she goes fishing with it. She lowers it and she raises it and lowers it real slowly. And the first time I saw her do that, I told her, "You're not going to catch anything." I could not imagine something flying into that one glob of glue by accident. And that's also the way I used to fish, and I didn't catch anything. But about 15 seconds later, a moth came in and got stuck in her glob of glue. She reeled it in and actually laid her eggs on it. And what I later learned is that was not an accident. She was releasing the sex pheromone of that particular species of moth. She had mimicked the sex pheromone. So he's a male. He thought she was a female. She is, but the wrong species. And every species of bola spider in the world mimics the sex pheromone of one species of moth. So you can have bola spiders in your yard if you have the plant that supports the larval development of the moth that your bola spider is mimicking the sex pheromone of. Highly specialized relationship. This is Phlox verrucata, very common spring ephemeral in our gardens and in the woods, and it spreads readily from seed, but only if it's pollinated. And if you look at the entrance to the corolla there, very narrow, I've always wondered what's pollinating phlox. I've watched native bees laying on those flowers. They can't get their tongues into them. So again, what is pollinating our phlox? And if you watch them carefully, you'll see it's day-flying sphinx moths. So things like this hummingbird sphinx or this snowberry clearwing, they have very long tongues. Right there, they sink them deep into the corolla of those flowers, and when they pull them out, they're covered with pollen. Then they fly to the next flower, and you get your phlox pollinated. So you can get your phlox pollinated if you have adult snowberry clearwings. You can have adult snowberry clearwings if you have larval snowberry clearwings, and you can have larval snowberry clearwings if you have coral honeysuckle, the native honeysuckle. That is their host plant. Now, even animals we don't think of as having specialized relationships with plants often do, at least at one part of their life cycle. And I'm going to use the Carolina chickadee as an example. So you have black-capped chickadee up here doing exactly the same thing. We always think of our chickadees as seed eaters because they are all winter long, one of the most common birds that are feeders. But when it comes time to reproduce, to make more chickadees, they're not eating seeds. They switch to caterpillars. They become caterpillar specialists. And if they're in an environment that is particularly rich, that's what they feed their young exclusively. And it turns out that they're not alone. Most of the birds in North America are rearing their young on insects, and most of those insects are caterpillars. So let's ask the question, why caterpillars? What is special about caterpillars? Could be that they're beautiful. Got a lot of beautiful caterpillars out there, like the curvilight owl. You have to look very quickly. The black swallowtail, very beautiful. The major day tannin, hieroglyphic moth, look fast. The spun glass caterpillar, that's one of my favorites. Or it could be that they have very cool names, like the green marvel, the once charred punky, the confused woodgrain, the cynical ground cat, the neighbor, the Donald. I know what some of you were thinking. Not that cat. Actually, I don't think it's because they have cool names or because they're beautiful. I think there's some very practical reasons. One of them is that most of these caterpillars are soft. And that means you can stuff them down the throat of your baby without worrying about injuring the esophagus. And that's probably important. They're also large. They're relatively large compared to many other insects. One medium-sized caterpillar is the equivalent of 200 aphids. So would you rather hunt 200 aphids or get one caterpillar? They're really nutritious. They're high in protein, high in lipids and fats, and it turns out they're the best source of carotenoids for breeding birds. So they're breeding early in the season. Now later on in the season, birds can get a lot of carotenoids from berries, but there are no berries early in the season. Carotenoids are compounds only made by plants, so we vertebrates don't make them, and there are a number of types of carotenoids, but it turns out that they are essential in our diets, even though we can't make them. In other words, we have to eat plants to make them. And that's why my wife Cindy tells me I have to eat my carrots to get my beta-carotene, I have to eat my tomatoes to get my lycopene, my whatever that is to get my lutein. She makes sure I eat all of that stuff because carotenoids stimulate the immune system. I'm just generally healthier if I have access to carotenoids. They are antioxidants. They run around my body and protect my DNA from oxidative damage. They improve color vision. So when your mother said, eat your carrots, you will see better, she was right. She didn't know she was right, but it turns out she was right. They improve sperm vitality. Who doesn't need that? Improve sexual attractiveness. Now we're talking about this male vermilion flycatcher here. He is bright red because he has taken the pigments that are in carotenoids and put them into his feathers. And of course, the brighter his feathers are, the more ladies he attracts. Back to chickadees. Chickadees they're vertebrates. They don't make their own carotenoids. So they have to get them from something that does. And yes, that something is insects. But here's the key. It's caterpillars that have twice as many carotenoids as other types of insects and 3 times as many carotenoids as spiders. We're not sure why that is, but it could very well be that for most birds, caterpillars are not optional parts of the diets. They are essential parts of the diet. And that means if you're in an environment, if you're a bird and you're trying to reproduce in an environment where there are not enough caterpillars, you're not going to be able to do it. Having almost enough caterpillars isn't good enough. You've got to get the young to the point where they're independent. So that is the next question. How many caterpillars does it take to make a clutch of chickadees? And the answer is it takes a lot. And it was these birds that told me that. I put a little chickadee box up in my yard, and I hung it low so I could set my camera up and take pictures of what they were bringing back to the nest. That's when I learned they were bringing back caterpillars, but I also learned they were bringing them back quickly. Because the parents, both the male and the female, are cooperating when they're foraging, somebody's always out looking for a caterpillar, they can bring one back to the nest once every 3 minutes. In one 27-minute period, they brought back 30 caterpillars. How do they do that? By bringing back more than one at a time, real quickly, and sometimes a whole bunch. And they're doing this all day long. They're working very hard, about 6 a.m. to 8 p.m. Okay, the next question is, how many species of caterpillars are they bringing back? This turns out to be important. In a 3-hour period watching them in my yard, they brought back 17 species of caterpillars. Now, the birds are foraging about 50 meters from the nest. They're not flying 5 miles down the road to get what they need. If they want to reproduce in your yard, they have to get what they need in your yard. And in a 3-hour period, they brought back 17 species of caterpillars that they found within 50 meters of the nest. That is important because if I had 1 or 2 species in my yard, and it happened to be a bad year for those species, as this year looks like it might be, those cool, wet springs are really hard on caterpillars. There wouldn't be nearly enough caterpillars for the chickadee to successfully reproduce. But if I have 17 species, or 34 species, or 134 species, and I'm measuring them, I'm counting them, I actually have a lot more than that. In combination, there will always be enough caterpillars, regardless of the weather, to bring these chickadees through for successful reproduction. So this is a case of stability, of diversity creating stability in the food web, diversity creating stability in the ecosystem. You've all heard that the diversity is good. That is why. A guy by the name of Brewer in 1961 decided he would count all the caterpillars that Carolina chickadees bring back to the nest every day. And it turned out to be between 390 and 570, depending on the number of chicks in the nest. And they're rearing their young on average for about 16 days until the young fledge. Now, after they fledge, the parents feed them caterpillars another 30 days. But nobody can count them because they're flying all over the place. So just to the point where they fledge, that is 6,000 to 9,000 caterpillars required to make one clutch of chickadees. And chickadees are tiny birds, third of an ounce. That's 4 pennies worth of bird. What if I wanted to make a red-bellied woodpecker? It's 8 times heavier than a chickadee. How many caterpillars does that take? And of course, we don't want just chickadees and red-bellied woodpeckers in our neighborhoods. We want a whole diversity of birds. We certainly want our scarlet tanagers and our tufted titmice and our blue jays and bluebirds and our tree swallows and common yellowthroats and indigo bunnings and towhees and yellow warblers and wood thrushes and wrens and cardinals and hummingbirds. All common birds we expect to be in our neighborhoods. Can you imagine the number of caterpillars required, not just to have a pair of them, but breeding populations of those birds? It's a very large number. And you might be thinking, well, we don't need any insects for Mr. Hummingbird here because it eats sugar water. Of course, it does eat sugar water, but only after it's eaten a whole lot of insects and spiders. 80 to 90% of a hummingbird's diet is insects and spiders, and then it goes to get the sugar water. And that is true for 96% of the terrestrial birds in North America. This is a list of the bird families that are rearing their young directly or indirectly on insect protein, 96% of them. By indirectly, I mean if these birds are eating spiders. Remember, spiders needed insects to become spiders. And this is news. This is news to a lot of people. It's news to people who write landscape for birds books because they will tell you how to put plants in your yard that make seeds and berries. We always want to make seeds and berries, and that's fine. The birds need seeds and berries, but they also need the insects to become birds in order to successfully reproduce. So we need to look at the plants that do that best as well. So there you go. No insects, no baby birds. Okay, how do we do that? What types of landscapes are capable of producing the diversity and abundance of insects that we're talking about here? Well, now we have to talk about the most common type of specialized relationship that occurs all over the planet, and that's the relationship between the insects that eat plants and the plants themselves. So we're not talking about pollinators here right now. We're talking about things like this polyphemus moth and the oak leaf that it's eating. Remember, plants don't want to be eaten. They want to capture the energy from the sun, use it for their own growth and reproduction. So they've loaded their leaves with nasty tasting chemicals, secondary metabolic compounds that make those leaves either bitter or downright toxic. And it's a really effective defense that keeps most of the insects of the world from eating most of the plants of the world. And that's why we can look outside, just a week or so, it'll be completely green. It's not because there's no insects out there that want to eat those leaves. It's because most of the insects that are out there cannot eat those leaves. They're too well protected. But we do know that insects eat plants. So how do they do that? How do they get around those chemical defenses? Well, they specialize. 90% of the insects that eat plants are what we call host plant specialists. They pick 1 or 2 plant lineages, and over great periods of time, they develop the adaptations required to circumvent the chemical defenses of those plant lineages. So they develop the enzymes that allow them to store and excrete and detoxify those chemicals, the behavioral adaptations, the life history adaptations that allow them to avoid those chemicals in time and space. But again, it takes a long period of exposure to those plant lineages for all these adaptations to fall into place. It does not happen overnight. Let's use the monarch butterfly as an example. We'll start out with what you already know. You know monarchs are specialists. They're specialists on one genus of plant, the Asclepias, the milkweeds. Now, there's nothing special about their specialization. All the other specialists that are out there are specialists just like the monarch. We happen to like the monarch because it's beautiful, but there's a lot of other insects that are specialists just like the monarch. Well, milkweed, of course, is a toxic plant. It's filled with cardiac glycosides that if you eat the milkweed, it will stop your heart if you eat enough of them, so don't eat any milkweed. But the monarch has the adaptation. It's got the enzymes to be able to deal with those cardiac glycosides. They actually store them in their wings and their blood so that they themselves taste bad, protects them from predators. But what about the sticky latex sap that's in milkweeds? Nobody ever talks about that. That also is a chemical defense. When we rip open a milkweed leaf, all that little white goo comes out. It gets on our hands, we don't like it. If you leave it on your finger for just a few minutes, when it's exposed to air, to oxygen, it gels, becomes like chewing gum. So now you imagine you are a monarch caterpillar and you're eating a milkweed leaf and you get this white goo all over your mandibles and it gels. It's going to gum up your mouth parts. You won't be able to eat. You'll starve to death. It's a very effective defense. So how do monarchs avoid getting their mandibles covered with that milky latex sap? You can watch this in your own yard. Watch your monarch. It'll first crawl onto a leaf. The first thing it does is go to the end of the leaf and starts to eat. If any latex sap starts to come out, it will stop eating immediately, turn around and crawl 2/3 back up that leaf and start to chew through the midrib. What it's doing is it's interrupting the canals that are ferrying that sticky latex sap down to the end of the leaf. So after it chews through the midrib, it can now go and eat all of the leaf that is distal to that little severing. And then it can turn around, there it is, it's eating without any sticky latex sap. But of course, the weight of the caterpillar often flags the leaf then, from the point where it chewed through the midrib. And that's very handy. If you're looking for monarchs, you can now drive down the road and look at a milkweed patch, and if you see those flagged leaves, you know there are monarchs there. All right, so the monarch has been able to get around the defenses, both the chemical and latex sap defenses of milkweeds, by specializing, and that is the upside of specialization. It allows this beautiful butterfly to eat a plant that is otherwise unavailable to most other insects. The downside of specialization is that now that's all it can eat. So by developing all the adaptations required to get around the defenses of milkweeds, it has not developed the adaptations required to get around the tannins that are in oaks, or the cucurbitaceans that are in cucurbits, or the cyanide that's in cherry, and on and on and on. The nicotine that's in tobacco. And what that means is, without milkweeds, we don't have any monarchs. And of course, that is exactly the situation we're facing now. We have never been very nice to our milkweeds in our residential landscapes. We haven't thought about it. They were always out there someplace. Most of the some places were along the edges of agricultural fields, but now we have a new ethic in agriculture, and that is weed-free, no weeds at all. We have Roundup Ready corn and soybean. We either have bare soil right up to the roadways, or we now mow. We have lawn. But we've gotten rid of the weeds. Those weeds are native plants. And it illustrates, we have a marketing issue here with native plants. If you call them weeds, of course everybody wants to kill them. Instead of calling it milkweed, we should call it Monarch's Delight. We got New York ironweed and Joe Pye weed and butterfly weed. They're all weeds. Let's change some names and people will stop trying to kill them. And of course, it's not just the monarch that uses those plants. It's all those other specialized insect herbivores. It's our native bees. We have 4,000 species of native bees using the forage from those flowers that are now lawn. So we need to get those native plant communities back into our landscape. I don't want you to think that it's just caterpillars, just butterflies and moths that are specialists. This is the elderberry beetle. It only eats elderberry. The dogbane beetle only eats dogbane. Sumac flea beetle only eats sumac. This is a Korean bug that only eats ash. So it's in trouble. If we lose our ash trees to the emerald ash borer, we will lose this insect. Dave Wagner at the University of Connecticut has just finished a paper. We'll lose 95 species that specialize on ash. And that is the problem, the fact that so many of our insects are host plant specialists. If we take away the plants on which they have specialized over many thousands of years, we will lose all of those insects. There's some good news. And that is we're learning more and more about what comprises food webs. What are the constituents of these food webs? And if we know what makes up a food web, we can actually rebuild it on purpose wherever we want. Let's talk about rebuilding a food web right in our yard. It's specialization that allows us to do this. Let's build a food web of a white-eyed vireo. And I'm going to use that as an example because that's the nest that my wife Cindy found in our backyard a couple of years ago. The birds knew that I needed to identify the caterpillars they were bringing into their chicks, so they built the nest very low, and I could set up my camera and take pictures. And we know a lot about what caterpillars eat. So if we can identify the species of caterpillar, we know what plant made that caterpillar, then you know what plant you need to plant in order to have white-eyed vireos. So let's do that for a few minutes. This is the blinded sphinx moth. It's a specialist on black cherry. We have a lot of black cherry at home, making blinded sphinx moths so the babies get to eat. This little guy is the chestnut chazura, and despite its common name, it's a specialist on native viburnum. So things like Viburnum dentatum, there's one right outside the door here to the building. That's a favorite host plant of chestnut chazura. We've got a lot of Viburnum dentatum at home, and they are making these little caterpillars so the babies get to eat again. That caterpillar is the drab prominent. It's a specialist on sycamore. Now, we did not plant sycamore at home, but there was a big wind 13 years ago that blew in some sycamore seeds. One landed in my cold frame, it germinated, and I'm not very fast at weeding things out, so it's now well over 40 feet tall. But it's making drab prominence, so the babies get to eat again. And on we go. That was the eight-spotted forester moth, a specialist on native grapes. We have lots of those. Lunate zale, another specialist on black cherry. This is the Spicebush Swallowtail. There's this little phony eye there that's supposed to scare the bird into thinking it's a tree snake. It didn't work this time. It's a specialist on spicebush and its close relative sassafras, and we have both of those. That guy's the tufted bird dropping moth, another specialist on black cherry. So black cherry is emerging as a really important food plant, really important part of this bird's food web. But these guys are hungry. We need a lot more than that. So let's put in some black walnut. We do that, we get the walnut sphinx, the great-edged bomoloka, the black blotch caesura, the bride. These are all specialists on black walnut. If we do native maples, we get Plagodes inchworms, the green-striped maple worm, the maple bantam dagger moth, and many others. Native elms, and you got a lot of native elms out there. The American elm will give you the four-horned sphinx, the double-toothed prominent, the interrupted dagger moth, and again, many others. Remember, 90% of the insects that you need to build these food webs in your yard will not be there if you don't put the plants that make those insects. So if you want the mustard sallow, you need witch hazel. If you want the hackberry emperor, you need hackberry. Cuculio asteroides needs native asters. The Arcigera flower moth. And brown coomba, the brown hooded owlet, all need goldenrod. Hog sphinx, Virginia sphinx, Abbott sphinx, Virginia sphinx. Now I'm getting all confused. That's the Pandora sphinx. The Abbott sphinx, only Virginia creeper. The redbud leaf roller needs redbud. The gray furculent needs native willows. The turbulent phosphilla needs greenbrier. And the orange tufted oneida, the spiny oak caterpillar, the two-spotted oak punky, the variable oak leaf caterpillar, the red-humped oakworm, the orange-humped oakworm, the pink-striped oakworm, the delightful dagger moth, the pleasant dagger moth, the lesser oak dagger moth, the greater oak dagger moth, the streaked dagger moth, the afflicted dagger moth, the white-blotched heterocampa, the oblique heterocampa, the red-lined panapoda, the laugher, and many, many more will not be there if you don't have oaks. Yes, we should all clap for oaks because it's the most important plant that you can put in your yard. Why do we want all these insects? And we talked about the birds needing the insects. Yes, they do. But it turns out insects are critical components of almost all terrestrial food webs that are out there. I mentioned spiders. All spiders eat insects, or they eat other spiders that eat insects. And I know a lot of people don't like spiders, but look who does. It's the second most important component of bird food webs. So just for the birds alone, we can't afford to lose our spiders, but they're also valuable predators that help keep those insects in check. Then we've got a lot of insect predators that are eating the insect herbivores. If we lost these herbivores, we'd lose the predators. They themselves are part of food webs. If we lost our insects, we would lose our frogs, our toads, all of our amphibians, because they all eat insects. So do our lizards, so do our bats, so do our rodents. That surprises a lot of people. We always think of rodents as seed eaters. And of course they do eat seeds when they can't find enough insects. But the reason they want these insects is that insects are really good food. Pound for pound, there's twice as much protein in insect meat as there is in beef. And they're filled with lipids with organs in their abdomen called fat bodies, loaded with lipids that allow these little guys to grow quickly, reproduce quickly. And if you're a mouse, that's what you want to do because there's so many things that want to eat you. Larger organisms eat insects. They're just really good food. The skunk is digging up your yard to get the grubs in your yard. Raccoons eat insects. Even things we don't think of as insectivores eat a lot of insects, like the red fox. 25% of a red fox's diet is insects. 23% of a black bear's diet is insects. Almost a quarter of these predators' diet is insects. So it doesn't matter how big you are. Even if you don't eat insects, you need insects. This is a sharp-shinned hawk. It's a bird predator. You might think, well, I can have sharp-shinned hawks in my neighborhood even if I get rid of all the insects. But think about it. The birds this guy's eating needed insects to become birds. So he needs insects indirectly. So does the garter snake. It's not eating insects, but it's eating the frogs and toads that eat the insects. So a world without insects is a world without biological diversity. And E.O. Wilson told us decades ago that a world without biological diversity is a world without humans. And that's why this is a really important message for everybody. Whether you like the life around you or whether you hate it, you absolutely need it. And it starts with those plants that make the insects that creates the rest of the life. What is happening to all of those things that need insects, all of those insectivores? We're not measuring it in most cases. The one case where we are measuring things, birds, we're measuring birds because we like birds. We have something called the State of the Birds Report. Comes out, I don't know if it's every year or every other year. I think it's every other year. And it says the state of the birds is terrible at this point. 2 years ago, the State of the Birds Report said that there were 230 species of North American birds at risk of extinction. Just 2 years later, that's now 426 species of birds in North America at risk of extinction. That's almost half of our birds at risk of extinction. We now have 1.5 billion fewer breeding birds in North America than we had just a few years ago. 46 species have lost half their population. None of these numbers are good. Why? Because the ecosystems supporting our birds are not happy. And again, this is an important message for us. Those are the same ecosystems that support us. Now, we can wait till they crash and then start to do something about it. We kind of like to react. But I don't suggest we do that. We need to start doing something about it right now. So the first thing we need to do is understand what is wrong. What's going wrong? We have parks and we have preserves. They are not preserving the life we need them to preserve. So why not? Well, there are a couple of reasons. I'm just going to talk about one of them tonight, and that's that they're too small. They're universally too small. When you take a large area like this and you shrink it down to a little habitat patch, and if I had flown here today and looked out the window, that's what I would see. I'd see little habitat patches all over the place. They don't have to be that small. But you're taking large populations and shrinking them down to small populations when that happens. And that's the problem. Small populations are highly vulnerable to local extinction. Why is that? Because all populations fluctuate. In good times they go up, in bad times they go down. If you're a large population, this top line here, even in your down cycle, there's enough individuals so you can increase quickly when times get better. But if you're a tiny population, in these normal fluctuations, you often hit zero. You blink out of your little habitat patch, and then you're gone. And unless you recolonize that patch, which is getting more and more difficult because our little isolated patches are isolated from each other. Very hard for these animals to recolonize. Then you're permanently gone. That's called local extinction. And studies all over the world are telling us the same thing. And some of these studies are quite long, 100 years in length. Our natural areas, the natural areas we've left on this planet, in most cases, are not large enough to preserve the nature we need them to preserve. And unfortunately, that includes our largest national parks. Okay, now I know you have a limited ability to absorb bad news, and before you even got here, you get a lot of bad news, I know that. We have a bad news cup, and when it's filled up, I can keep pouring into it, but you won't remember any of it. So just a few more drops of bad news, and then we'll talk about some good news. Not only have we fragmented and isolated the natural world, these little habitat fragments, we've also created what we call invasive species by bringing in organisms from someplace else. When we bring in plants and animals from someplace else, we do that and leave their natural enemies behind. So the definition of an invasive species is a non-native, let's just talk about plants, a non-native plant that is aggressively displacing native plant communities. So what you have now is a plant probably from Asia where you used to have a diverse community of native plants. And we now have 3,300 of these species in North America doing that. Here's an example. This is White Clay Creek State Park. It's one of those little parks and preserves that I drive by on the way to work at University of Delaware. There's a period in the spring, and I know it happens up here as well, where the plants from Asia leaf out before the plants from North America. It's a wonderful time to look into your natural areas, and whatever's green doesn't belong there. And that's what you're looking at here. Every bit of the green you see there is a plant from someplace else. And it's all of our favorites. It's multiflora rose and Oriental bittersweet, and Japanese honeysuckle and bush honeysuckle and miscanthus and privet and Norway maple and ailanthus and Japanese knotweed. They're all there. And all of them are escapees from our gardens. So we don't have to wonder where these guys come from. And in many cases, barberry, in many burning bush, we're still selling them in many of our nurseries. So now more than a third of the vegetation in White Clay Creek State Park is not supporting the specialized relationships that run the ecosystems in that park. Now you can measure what happens when we allow either invasive plants to take over a native plant community or when we plant these plants ornamentally in our yards. So whether or not these ornamental plants from someplace else are actually invasive, whether they're moving, they now become the first trophic level. They're the plants that are supposed to be supporting life in our yards. We've been measuring that, the consequences of that in my lab for, I guess, the last 12 years now. We've got lots of published papers, and you can go read the results. I know you're not going to. We'll make it easy on you. We always get the same answer. Or you could do my 12 by 12 experiment. This is something you can do right at home. You can do it this summer. Get the school kids to do it. That's 12 feet by 12 feet. Marked out, and so here it is marked out in a lawn. Now you get to decide how much life is going to exist in that space by determining which plants are in that space and how many of them. So we can keep them keep it as lawn. We get on our hands and knees on Wednesday and count all of the biodiversity in that 12 by 12 section. It won't take us long. And then of course on Saturday we mow it and kill it all. Or we could put a tree in it. Let's put a white oak in there. Now here's one I planted from an acorn 14 years before I took that picture. Proves two things. It was free, planted as an acorn. And it also grows. Oaks grow. You always hear all the time, don't plant an oak, you won't live long enough to enjoy it. I'm enjoying it. It doesn't have to be 300 years old before you can enjoy your oak. All right, let's do our 12 by 12 experiment. Let's walk around. That fills that 12 by 12 section very nicely. Let's walk around and at head height, count the caterpillars, the bird food that is on that particular white oak. Now just at head height, we're not climbing ladders or anything. And let's do it on July 25th of 2014. We're going to find 410 caterpillars from 19 different species. Then I'm going to stand back and take that very picture so I can ask you, how many of those caterpillars do you see? How much of the caterpillar damage do you see? That's what we worry about. I don't see any. And this is the distance at which we view our trees. But if I knocked on your door and said, you've got 410 caterpillars on your oak tree, get the spray can, call the man, save the tree. You don't have to save the tree. That's what oaks do. They're passing on part of their energy to a moth caterpillar, and soon it'll be in the belly of a bird. You have a living system in your yard because your oak is willing to share some of its energy. I met a woman named Tallamy in New Orleans a couple of months ago, and she says we should all practice the 10-step program. Take 10 steps back from your trees, and all of your insect problems disappear. I think that's great advice. Okay, 12 by 12, let's go to a black cherry now. There's a black cherry, same size, walk around. 12 by 12, count the caterpillars, 239 caterpillars from 14 different species. Now let's go to my neighbor's house, who moved in the same month that we did. He had different plant choices. We both have 10 acres, but he really liked calorie pears. You might know it as Bradford pear. It's one of these ornamentals from Asia, which has turned out to be highly invasive. He liked it so much he planted 32 of them. So the first thing we have to do is decide which one of them we're going to count or measure. Let's count this one. Actually, the first thing we want to do is make sure he's not home. Okay, we'll walk around 12 by 12, count the caterpillars on that tree. I did find a caterpillar. I found one inchworm from one species. Then I went to his burning bush. And by the way, I'm pulling these plants out of my property all all the time. 12 by 12 section, count the caterpillars. I found 4 caterpillars from one species, 4 little leaf skeletonizers that are too small to be part of a local food web. Okay, and, in science you replicate. You do it over and over again, or you design an experiment with replication built in to see whether the pattern you're noticing is real. So let's do it again the next day, July 26th. We're going to use the same species, but we'll pick different plants. And we get the same pattern. Different numbers, but the same pattern. We get 233 caterpillars on the white oak, 53 on the black cherry, 2 on the burning bush, and 1 on the calorie pear. And that is the pattern you're going to get over and over and over again. There are really not very many, a few genera of native plants that are producing most of the food that is out there, and these genera from other places that we bring in primarily as ornamentals are unable to do that because they have not been here long enough to develop the specialized relationships that support our food webs. And don't think if they're here a few more years, those relationships are gonna happen. It takes tens of thousands of years for these relationships to fall into place. Rick Dark and I gave a talk at Williamsburg, Virginia, 2 springs ago. On the way home, we drove across the Bay Bridge, up the eastern shore of Virginia and Maryland. We got to the Sunset Beach Inn and Grill. And we stopped, take a picture, because there we have all the calorie pears, all the Bradford pears in full bloom, and that is one of the reasons people plant them. It's also probably the cheapest tree you can buy. Has some nice fall color, but the first ice storm that comes along, it takes it down. So these things don't live very long. But apparently the Sunset Beach Inn and Grill really liked them, and that's the only tree they planted. Okay, we kept driving, and the very next property, right past the Sunset Beach Inn and Grill, looks like this. This is, I don't know how many acres it is, but it's owned by a land conservancy. Of course, they bought that land to try to preserve it, preserve some function, and now it is thoroughly invaded with the offspring of those ornamental trees. That's what a plant invasion looks like. And this property, which could be supporting chickadees and a bunch of other things, is now making 1 caterpillar. Remember, these birds eat thousands and thousands and thousands. So it's ecologically castrated. It's biological pollution. It's whatever you want to call it. But that is a serious, serious problem. And I can drive from New York all the way to Richmond at a particular week in the spring, and it's white all the way down on both sides of Route 95 because of calorie pear that has escaped from our gardens. Okay, what does this mean in terms of pollinators? So we talked about what's happening to our caterpillars. Well, what if we have Japanese knotweed invasion? And we do have Japanese knotweed invasions. That's what it looks like. It supports 0 species of specialist bees. So we've got bees out there. We've got the honeybee, of course, which is from Europe and Asia, and yes, it goes to the flowers of Japanese knotweed. But what about the 4,000 species of bees, native bees, many of which are specialized on particular plant genera? Well, knotweed supports none of those, but look what does in New England. This is goldenrod that supports 11 species of specialist bees. That means they're only going to goldenrod. So if the knotweed takes out the goldenrod, you've lost 11 species of bees. If it takes out your native willows, you've lost 8 more species of specialist bees. If it takes out your asters, you've lost 7 more species. So right away, by losing those 3 genera of native plants, you've lost 26 species of native bees that only go to those genera. That's the consequence of replacing our native, diverse native plant communities with these plants from out of town. All right, if we're not going to plant Japanese knotweed, if we're not going to plant calorie pear, what are we going to plant? That's a list. It is a ranked list of all of the woody plant genera in the mid-Atlantic states. And this is the first list we make. We like to make lists in my lab. We were doing it for one reason, but it's ranked from the ones that support the most to the ones that support the fewest caterpillars. So we're thinking of these caterpillars as bird food. The little numbers after each species or each genus of plant are the number of species of caterpillars recorded on that genus in the mid-Atlantic states. So normally I ask you to memorize that, but I know that'll be a real challenge now. It has been available on my website, but I'm going to give you a better way to get to it. My website's terrible. I never go there. It turns out that this was a valuable resource. People saw this list and they said, hey, if we use the plants from up here, we can rebuild life in our yards much faster than if we just do a random hodgepodge of the plants available at the nursery. So everybody wanted a list. I go to Wisconsin, they say, where's our list? Because this is the mid-Atlantic states. If I go to Florida, where's our list? California, where's our list? Well, it took my technician 2 years to make these lists. There's one for herbaceous plants too. 4,000 references, a lot of work. And I said, if you pay my technician, she will make you a list. They didn't. But actually, the Forest Service said, this is good. We will pay your technician 1 year, and we want a list for every state in the union, and we want a list for every county in every state. Can she do that? It's really hard for me to find support from my technician, so I said, of course she can do that. Turned out she couldn't do it, but she did do it. It took her 1.5 years. She got much faster at it. It's now launched on National Wildlife Federation websites called Native Plant Finder, and that's the URL. I'll give you a few minutes to copy that down. They're going to give me some cards so that I can hand them out. But you can find it on the National Wildlife Federation website. And the idea here is that you can put in your zip code, and the ranked list of herbaceous and woody plants will pop up for your county. So you don't have to guess about it. Now this is in beta testing. And we already know that the very expensive web designer that we hired kind of left off a lot of plants. So we're fixing that. But if you see a mistake, you want to tell me about it, that's great. We're still working on it. But soon will be a very powerful tool. You're welcome to use it right now. The one thing I did notice by having access to data from all over the country is that there really are just a few genera of native plants that are producing most of the food. So if you look at all the available genera of native plants in your area, there's just a few of them that are producing most of the food. And I started calling them foraging hubs. I borrowed that term from the people that study fruit-producing trees in the tropics. All the birds go to those trees to get the fruit, and they called them foraging hubs. I have since learned that you don't like that term. But I was sitting on a Delta airline one day and the tarmac not going anywhere. And so I was looking at the Delta magazine, and there are all the Delta hubs. I said, that's exactly what I'm talking about here. Let's make them foraging hubs. There we go. They're foraging hubs. Now, all the lines going into these trees could be a bird, could be a species of bird, could be a lizard. It's something going into this oak here, or this cherry, or this willow, to get a good meal. The important point here is that all these other black dots, those are other plants in the landscape, and there are lines going into those as well, but not very many, because they're not making very much food. So imagine what would happen if we took these 4 foraging hubs, those very powerful genera, out of the landscape. We would still have dozens of other types of plants there, but it would be a failed food web. So this is new information that we've found out, and it's going to be a really powerful tool for conservation. We can rebuild food webs, but they better include those foraging hubs, or they're not going to work. So that's about 5% of the genera. 5% of the genera in your area are producing about 75% of the food. You can turn that on its head and say that 95% of the available genera, 95% of the plants that you have access to, and if you leave out these really powerful genera, that really powerful 5%, you still will have a failed food web. So it's not the number of types of plants you have in your yard, it's whether or not they're those powerhouses. If you don't like foraging hubs, call them core genera, or keystone genera, or hosts with the most, whatever, super plants, whatever you want to call them, they need to be in our landscapes. If you're wondering what to put back after you pull your invasives out, those are the guys, They occur everywhere. Those are our bioregions in the country. Every single bioregion shows that pattern. Doesn't matter whether you're in the north or the south, the same pattern exists. So all we need to do is learn what the foraging hubs in our area are, and we are well on our way to restoring food webs. In this area, it certainly is oaks. 557 species of caterpillars recorded on oaks in the mid-Atlantic states. What does that mean? Let's compare that to ginkgo biloba, a plant from Asia, planted in our cities all the time. Now, our lists say that they support 4 species of caterpillars, but we've tracked it down. As far as we know, those are all mistakes. Those are mistaken host records. And I don't have time to tell you how you get a mistaken host record, but it's not as hard as you might think. So I've told people, if you ever see a caterpillar eating ginkgo, take a picture of it and send it to me. And years, nobody has sent me a picture. So I'm going to say that 4 is really 0. But even if it is 4, 557 species of bird food versus 4, which one would you plant? if you wanted to support the life around you. Number 2 on our list are native prunus, the black cherry and pin cherry and American plum, Chickasaw plum, 456 species of caterpillars on black cherry. Let's compare that to Zelkova. I don't know if you're using a lot of Zelkova up here, another plant from Asia, but we sure are using it, lining our street trees, or our streets, probably because it looks a lot like the elms that we lost to the Dutch elm disease. 0 caterpillars on Zelkova. So, if that is your goal, if your goal is to put plants in your yard that will not interact with anything, they'll always be perfect, Zelkova is for you. But, why don't you plant a silk Zelkova or a plastic one? And then you don't have to water it. It'll be just as interactive as the living one. Pieris japonica might be the most common foundation plant in North America. This illustrates an important point. We have native Pieris. But you know what? It's not a very productive genus. Only 2 species of caterpillars recorded on native Pieris. I don't think Pieris japonica has anything. Could be a native viburnum that has, 103 species recorded on. So those are the decisions, or those are the consequences of the decisions we make when we landscape our yards. Try to think of the landscape or the plants in your yard as if they were bird feeders. There you go. They're bird feeders. Now you get to determine how well you're going to feed the birds. You can feed them a lot, or you can feed them just a little bit. This is what the landscapes around me look like. They're giant lawns with very few plants in them. You can put food in your bird feeders. In other words, put plants that are making those caterpillars. The birds are not eating the feeders themselves, or you can keep them empty. There's the ginkgo back there. It's a big tree, but it's not making any food. And when we landscape without these very powerful genera, these foraging hubs, we are not fooling the birds. Here's a little bit of data from my PhD student, Desiree Narango, who's working with Carolina Chickadee in the suburbs of Washington, D.C. She's following 92 pairs of breeding chickadees and looking at their breeding success in relation to the plants in the landscape in which they breed. And she can control that because chickadees are tree hole nesters, so if you put up a chickadee box, they'll work hard to use it because there's never enough tree holes. Right there, so this is the territory of one of those pairs. The star is where the box is, the chickadee nest. This red line represents 90% of the foraging area. So 90% of their foraging occurs within there. Maybe it's 95% occurs within this area here. Then the blue areas are the plants on which they're doing all of this foraging. So let's look at what they are. I don't know if you can read that, but they're all the native trees in this neighborhood. So we've got basswood and sweet gum, American elm, black cherry, and 2 species of oaks. Equally important here, though, is to look at the species of trees that chickadee is not going to. And those are all the plants from someplace else, mostly Asia. We've got Japanese maples and silk tree. There's our friendly ginkgo, black poplar, crepe myrtle, saucer magnolia. And it's very easy to picture a landscape where those are the dominant plants. And when that happens, that's a failed nest. So after Desiree took the 3 dead chicks out of that nest, she noticed a bunch of sunflower seeds in the bottom of the nest. Now, remember, baby chickadees cannot eat sunflower seeds, so this was a little unusual. And what she thinks happened is that this was in a terrible landscape, that the parents simply ran out of caterpillars. Somebody had a bird feeder up, so they tried to feed them these seeds. And, of course, they can't eat them, so the chicks starved to death. There are real consequences to the way we landscape. Now, here's some data that she just gave me. We'll make it simple here. If you're starting with a landscape that's all native plants versus a landscape that is 80% non-native plants, and we've measured suburbia around where I live, 80% non-native plants. So it's not a stretch. You will end up with 2.5 times fewer fledglings in this 80% non-native landscape than in the 100% landscape. So if you start with 100 females, you'll end up with 200 fledglings, which is replacement, because the female is replacing herself and the male, and that's a stable population right there. 82 fledglings is way below replacement rate, so this is a declining population. This is an ecological trap or an ecological sink. All the birds are going there and they're not replacing themselves. Again, real consequences to landscaping with plants from someplace else. That is a picture, those are all birds in there, of 51 species of migrating birds that are using the properties that Desiree is working in as stopover points when they migrate. Our migrants, so your migrants don't fly around cities. That's impossible these days. They fly right through them. They fly all night long, and at the end of the night, they're out of gas. If they've had a tailwind, they could have flown 300 miles. They have no more energy, so they have to rest, yes, but what they really have to do is eat. They've got to restore the energy so they can continue their migration. And if they come down in the land of ginkgo, and that's what many of our cities look like, there's no food. And that's the end of the migration. We don't have to wonder why we've got 426 species of North American birds in trouble. We're starving them. So you don't have to save biodiversity for a living, but I strongly urge you to consider saving it where you live. Because we humans are pretty much everywhere. If we don't save biodiversity where we are, it's going to disappear. We have moved plants and animals all over the world, creating what ecologists now call novel ecosystems. A novel ecosystem is defined as one in which the organisms are just meeting each other for the first time in evolutionary history. So they're just now getting together, and what that means is they have not had the time to build the specialized relationships that are nature. And that means when we move plants and animals around and create these novel ecosystems, we're losing species, because all those specialized relationships drop out. If we're losing species from our ecosystems, we might want to ask the question, how many species do we need? Do we humans need? Let's be selfish about it. And the answer is, we need all of them. We need all of them because it is the living things in our ecosystems that are running those ecosystems. We talk about ecosystem services, we really should talk about biodiversity services. And those are the services that keep us alive. The Millennium Ecosystem Assessment, way back in 2005, measured the Earth's ability to support humans by producing ecosystem services. They had over 1,300 scientists worldwide measuring this. It took them 5 years. And their unhappy conclusion is that as of 2005, we have already destroyed the Earth's ability to support us by 60%, reduced the Earth's ability to make those ecosystem services by 60%. That's the ocean, by the way. That's not a recycling plant. And that guy's going out to fish. I wish him luck. So that's the same as taking planet Earth here and shrinking it by 60%. At the same time that we're increasing our population, we're increasing the economic growth all the time, we're taking more and more from poor planet Earth and making it smaller and smaller. We've turned the world into Gone with the Wind here because we've looked at our landscapes only from an aesthetic perspective. We've come to see plants as decorations, and we love these giant lawns that give us the savanna look. But we could grow the Earth again. We could rebuild it by putting the plants back that we have taken away when we rebuilt when we build those Gone with the Wind landscapes. We need to raise the bar about what we've asked our landscapes to do. In the past, we've asked them to be pretty. We can keep doing that. We know how to do that well. But they also have to support life. If we don't support life where we live, it's going to disappear because we are everywhere. They have to sequester carbon. Way too much carbon in the atmosphere. A third of it has come from us chopping down the forests and removing the plants on our landscapes. And all of that carbon is up in the air. If we put the plants back, put the trees back, we can pull an awful lot of that carbon out. What are those trees going to do? They are then going to clean and manage our water, manage the watersheds that we all live in. Everybody lives in a watershed. Nobody has the ethical right to destroy that watershed. We just don't think about it when we landscape. And they're also pumping carbon into the soil. The soil scientists have been too quiet about climate change here, but now they're starting to speak up. Our soils can store 7 times the amount of carbon, total amount of carbon that's in the atmosphere right now. 7 times the amount, if we get it back in the soil. How do we do that? Well, we don't do that. The plants do that. They pump. After they build their bodies out of carbon, they pump it into the soil. And of course, we need to support our pollinators. Supporting pollinators is now politically correct. And of course, by issue, why do we need pollinators? I almost always get the answer, because they pollinate our crops. And they do. A third of our crops are pollinated by animals. But you know, I don't like that answer, because they pollinate 80% of all plants and 90% of all flowering plants, not just our crops. If we lost our pollinators, we'd lose 80 to 90% of the plants on the planet. Not an option. It is simply not an option. So we're not talking about good land stewardship here, we're talking about essential land stewardship. And I'm still amazed that I did not hear about this in the last presidential debate.
Yeah.
There's a family that lives in this house. And if they're not creating all the ecosystem services they need at home, they're going to have to borrow them from someplace else. Now, in the past, we borrowed them from nature. There's not enough nature left anymore, believe me. These guys are not going to borrow them from their neighbor because he's not making any either. They're not going to borrow them from their open space in their township if it looks like the open space in my township, which is that. It's a giant lawn, manicured lawn with a paved path around it, and people walk in circles around it. We think if there's not a building on a land, then that's good land stewardship. But it's not. That's not good land stewardship. That's a house down the street from me. He's very proud of his lawn, but that yard is not doing any of the things I just listed. It's not sequestering carbon. It's not helping pollinators, or it's destroying the watershed. It's certainly not supporting food webs. All of those plants are calorie pear, Bradford pear, so it is adding to the invasive species problem. Not good, not good. We've looked at the amount of trees that are in typical suburban neighborhoods. It's only 10% of what could be there compared to nearby woodlots. And they're typically short-lived ornamental plants like the calorie pear here. They're going to fall over in 30 years and release all the carbon that they have sequestered. We need to get the big guys back there. Get those big oaks, those hickories that are going to hold that carbon for hundreds of years. And of course, we can't look at a yard like this. There's my neighbor's house with his 32 calorie pears. And say we rebuilt food webs. As I said, he's got 10 acres, and every plant he's put on that 10 acres, every single plant he's put on that 10 acres is a non-native plant, and most of them are invasive. And again, why has he done that? Well, he's done that because he doesn't know anything about plants. It's not his fault. He just copies the other neighbors. He can't see me. So when he goes to the nursery, he buys something that's pretty. Again, we think plants are just decorations. Maybe they could be screens and anchors or focal points, but it's all been about aesthetics. We have not considered the ecological roles that these plants have to play at home. But we could. We could have pretty plants that also have food web values, so helping our watershed, sequestering carbon, saving the pollinators, doing all of those things. So let's talk quickly about how to do that. What does a biodiversity-friendly neighborhood look like? These are the things that need to happen. We need to put enough plants back where we humans live that we create biological corridors connecting the isolated habitat fragments that we have out there. If we do that, if we connect those fragments, they're not isolated anymore. And if they're not isolated anymore, the populations within them are not tiny. So when they fluctuate, they won't disappear anymore. Building these biological corridors right through our neighborhoods is the most important thing we can do to stop the steady drain of species from those neighborhoods. Where are we going to put all those plants? I say we put them in the area that's now in lawn. We have 45.6 million acres of lawn. That's equivalent to the size of New England that is now in lawn. And we're adding 500 square miles of lawn to the U.S. every year. Why are we doing that? Because lawn is a status symbol. But you know what? We can change our status symbols. We can change them. I went to Montana a few years ago, and I looked around. They didn't have big lawns. And I asked my host, where are your big lawns? He said, well, we only get 9 inches of rain a year. He said, but lawn is not a status symbol here. And I said, no, why not? What is your status symbol? And he thought about it. He said, big belt buckles. And I think that is the answer. Because if we double the size of our belt buckles and cut the size of our lawn in half, I think we've got it. Then, of course, we want to build those corridors out of those really powerhouse plants. At least they have to be part of it so that we can support the life around us. This is what we've done until now. We build our house, put in our foundation planting, a few trees here and there, then we're exhausted, no more landscaping, so everything by default has become lawn. Let's turn that on its head. Let's build the house and now figure out where we do want lawn. I am not suggesting we get rid of turf grass because it's the perfect plant to walk on without killing it. We just have to figure out where we're going to walk. Where are you going to walk on your property? I look at where my neighbors walk on their 10 acres. Nowhere. Never outside. But what if you want to get married in the front yard? You certainly want some lawn there. If you want to walk to the backyard, a grass path, throw the frisbee, have a barbecue. Where are we going to use your yard? That's where the lawn goes. Then everything else by default becomes heavily planted. And that becomes the landscape design challenge of our times. How do you get all those plants into your landscape without it looking wild and messy? You can do it, and if you convince your neighbors to do it too, now you have the connectivity with the woodlot over here and the woodlot over here. And not only have you stopped the steady drain of species from your neighborhood, you've reversed it. They will start to come. We still have lawn, so you still play with your lawnmowers, it'll be okay. If we do this in half the area that's in lawn, let's make the math simple. Let's say we've got 40 million acres in lawn. We can cut that in half and create a new national park that'll be 20 million acres in size, which will be, we're going to do it at home, so we'll call it Homegrown National Park. It'll be bigger than the Adirondacks, plus Yellowstone, plus Yosemite, plus Grand Tetons, Canyonlands, Mount Rainier, North Cascades, Badlands National Park, Olympic National Park, Sequoia National Park, the Grand Canyon, Denali, which is huge, the Great Smoky Mountains. You add up all those parks, it's still less than 20 million acres. So let's do that. Let's take an area like this. This is the entrance to the Toledo Zoo with a very nice grass path filled with dandelions here. Let's turn it into this. And when they did this, the board of directors went crazy. They said, nobody's going to come to the zoo anymore. They did. They got a lot of pushback. Let's take areas that look like this, treeless, and put the trees back. I hear all the time, we can't put big trees in small lots. Well, go to the south, where they love their giant spreading live oaks. They have found a way to do it. If they can do it, we can do it too. There's the grass. That's the new ethic in agriculture in so many places in the country. No more weeds here, mowed lawn. It could be that. Both of those shots are from Iowa, so it's starting to happen. We can take these square things here and turn it into a landscape like this. This is Fisher's Island. Of course, High-End Island off the coast of Connecticut here. I should have taken more of the house there. It's where the Roosevelts live. That is the perfect landscape for doing the things that I'm talking about. It does everything except support those pollinators, so let's put in a pollinator garden as well. We can take this mulch sculpture, which proves you cannot use native plants in a formal landscape, except nobody told the people in Indianapolis this is a formal garden, all native plants, first year of the planning. And of course that is an urban legend. Formality is a function of the design. It's not a function of the plants that go in that design. Our native plants are used in formal designs in Europe all the time. And it's okay because they're non-native plants over there. This is a corporate landscape, invites the employees to come out at noon to get sunburn. Could be a lovely setting like this. And really interesting research has shown if you spend just 15 minutes walking around a landscape like this, there are measurable medical benefits. Your blood pressure goes down, your stress hormone, your cortisol goes down, your cancer is cured, and you don't get divorced anymore. Why do I say that? Research has shown that you get the same benefits that you get from intense meditation, and that has been shown to boost your immune system. It also restores your attention span. Our attention span is eroded all day long, and it makes us crabbier and crabbier, and we can't learn, we can't do anything very well. 15 minutes in a space like this, your attention span is restored, and when you go home, you don't yell at your spouse. So I'm going to put another ball up there, call it mental health, call it human health. If you put a tree outside of a hospital room, the patient gets better faster. If you put a tree outside of a classroom, test scores go up. Everybody's scratching their head, why is this happening? Apparently it's the connection with stress. These plants, these natural settings lower stress, and when we are less stressed, we do everything better. How do you know when you have succeeded? When you have holes in your leaves. This is holistic gardening. That's a shingle oak leaf, and like the white oak in my yard, it has passed on part of its energy to a caterpillar, which is now in the belly of a bird. Now, I know this used to be a signal to grab the spray can, but it shows this tree is doing its job. We now have life in the yard because this tree is willing to pass that on. So if you don't have holes in your leaves, there's something wrong. You're missing huge components of life from your yard. If you have lightning bugs or fireflies, whatever you want to call them, they're not bugs or flies, they're actually beetles. That's what the adults look like, and of course they flash to signal each other when it's time to mate. And so many people come up to me and say, the lightning bugs have disappeared. I used to see them when I was young, but I don't see them anymore. If your lightning bugs have disappeared, it could be because you rake up all your leaf litter. They live as larvae in leaf litter, where they're predators on other arthropods. So if you neaten up the gets rid of your lightning bugs. If you have chem lawn, you have poisoned them. If you have security lights on all night long, you've made it difficult for them to communicate as adults. So if you get lightning bugs back, you're doing several things right. The best indicator, though, of success is breeding birds. If you have birds actually nesting in your yard, that is a great sign, because that's not going to happen if you don't have enough food to support nesting. And I'm going to leave you with just one example of how easy this can be. We can save nature, but only if we learn to live with it. Like the people in South Florida have done, they have successfully saved this beautiful butterfly, the Atala butterfly, from extinction. But what's interesting is they did it by accident. They did it by accident. How'd that happen? Well, it's a lycaenid butterfly that's beautiful as an adult, it's beautiful as a larva, it's beautiful as a chrysalis. And it is an extreme host plant specialist. Eats one species of plant, the kunti, native cycad in South Florida. Well, kunti has an interesting history, has a lot of starch associated with its roots. And the Seminole Native Americans used to use it as a source of starch. And when the settlers came to Florida, they taught them, hey, there's a lot of starch in kunti roots. Around 1900, somebody said, let's start a starch industry. And they did. 80% of the people that answered the census around 1900 in Miami identified their occupation as starch gatherers. And they did. They gathered all the starch, turned it into the starch that was in our shirt collars, eliminated kunti from the wild, extirpated from the wild. There were a few plants in gardens, but it was removed from the wild. So, of course, the butterfly disappeared. You can't take away its only host without it disappearing. Well, then we got the Endangered Species Act in 1973, and there was a desperate attempt to find some Atalas somewhere in Florida so they could get it listed as an endangered species, so they could get some federal funding and try to save it. And they looked all over the place, but they couldn't find any. So instead, they got it officially listed as extinct. But about that time, the horticultural trade recognized kunti as a valuable landscape plant in South Florida. It's a low-growing evergreen shrub that does well in the sandy soils down there. So they started to promote it. And big plantings like this are now commonplace, both in parks and people's yards. And look who showed up again. So I used to say nobody knows where it came from, but apparently somebody's just found a remnant colony on one of the keys, which is out colonizing the mainland now. And that is what I love about this story. It truly was an accident. They never got the Atala listed as an endangered species, so they never got one dime of conservation money to save it, which is good, because we don't have very many dimes of conservation money. The only thing they did was add one plant to the palette that is commonly used in residential neighborhoods in South Florida, and the butterfly saved itself, which shows that this type of residential landscaping is a very powerful conservation tool. If we could save this butterfly by accident, think what we could do if we made conservation a conscious goal of residential landscaping. And I think it's going to work. Because nature has proven to be a lot more malleable and resilient and forgiving than I ever thought she would be. But I guarantee she is not endlessly forgiving. There's a point beyond which she will not bounce back. But I think she will give us one more chance. And remember what the Donald says, make America native again. Thank you very much. Questions and answers now, so think hard about those questions.
Doug, where can I get a bumper sticker that says "Make America Native"?
That's a good idea. Make one yourself, you make a lot of money.
All right.
Have you tried to educate your neighbors, the ones you've taken pictures of, their properties?
Right. No, I haven't. And here's why. It's very hard to go to your neighbor and tell them they are living wrong, they need to live like you. You have to get along with your neighbors. It's easy to talk to you guys, I don't know you, if I offend you, I'm sorry, I'm not trying to do that, but you have to live with your neighbors. And nobody wants to be told they're doing it all wrong. The only thing I can do is provide an example and hope that it interests them. It's not gonna interest. There's a sign down the street, and my neighbor's all for it, says evolution is a lie. It's just not going to happen. And I hope he never reads my book.
Thank you. So we've only been living in our current residence about 2 years with a lot of garlic mustard and oriental bittersweet. And so far, the only way we've found to be able to control it is to mow it down. It's a lot on the side, and our neighbors may or may not be controlling theirs. So how do you start to make that transition to putting plants in that area when the only way to keep this bad stuff out is to mow it down?
Well, it's not the only way you can do it. It is the only way to do it if you don't use herbicides. And a lot of people don't want to use herbicides. It's an easy way to do it, but that's an excellent question. How long do you have to mow before you kill the rootstock? You can kill the rootstock of garlic mustard pretty fast, but oriental bittersweet, very hard. If you don't allow it to ever green up and gather more energy to build the roots up, you eventually will exhaust the nutritional stores in those roots, and it will die. But the rootstock of oriental bittersweet is very large, and that may take a while. So you're right. You're stuck there. You're making a dead zone while you're trying to control it, and that, of course, is why people do use herbicides. They chop it off at the base and they paint it, and if it's done properly, you can kill it almost overnight, and then you can start your rebuilding.
What should we do about the gypsy moths? They've been advertising on the news the past few weeks about how they're coming out and people are putting tape on their trees to catch them. Should we just leave them for the birds to eat?
Yeah. All right, gypsy moth. What we really do about the gypsy moth and the winter moth and the emerald ash borer and the hemlock woolly diligent and the longhorn Asian beetle and all these other insects we've brought from someplace else is to not bring them here. And I know that's stupid to say because we have brought them here. But once they're here, it is a huge problem. So I'm talking about making insects, but I am not promoting non-native insects because, again, they're here without their natural enemies. They go crazy. They're destroying our ecosystems just like the non-native plants. Okay, gypsy moth is here. What are you going to do? It is a tough problem. If you live in an area where the soils are shallow and you have a bad gypsy moth outbreak and you have a drought on top of it, 2 years of defoliation will kill your tree. Do you want your oaks to be killed? No, you don't. Now, gypsy moths are cycling, so they're outbreaking now. But look at all they were not outbreaking for 20 years before that. So the object is to get through this period of outbreak. Hopefully, you're getting a lot of rain this year, so I think the fungus that actually controls them will outbreak. When we spray for gypsy moth, you're not just killing gypsy moth, you're killing all the other caterpillars too, so you're really setting back reproduction for the birds that year. Why don't the birds eat gypsy moth? Because it's a hairy caterpillar. Most of our birds cannot eat hairy caterpillars. The hairs get stuck in their esophagus and their stomach. We do have two that can, the yellow-billed and black-billed cuckoo, because they are specialists on hairy caterpillars. And they have the ability to throw up their lining of their esophagus and their stomach, and they do that periodically. And they will actually follow gypsy moth outbreaks in order to eat them. Tent caterpillars as well, fall webworm as well. But there's never enough cuckoos. So if you have a favorite oak tree, if it's really bad, the burlap bands, of course, will the larvae come down at night and spend the day under there. That you can kill them then, but very tough to control them. So yeah, I don't have a silver bullet for them.
Yes, up here, the follow-up to the preceding question about how to succeed once you mow down the invasives will be the subject of those workshops a week from tomorrow, the 20th, as Leon explained. Though Doug will not be there, numerous invasive plant managers will be present to answer your questions at the Houstonic Valley Regional High School North Campus, 9:30 to 11:30, and at Merringmoor Preserve Sharon Land Trust from 1 to 3. The brochures that were distributed upon your entering were provided by the Sharon Land Trust, and thank you very much for providing those.
Question about, you were promoting oaks as the tree for caterpillars. We, of course, have a lot of maples, and one of the trees that we plant a lot is the Acer rubrum. Is this a good tree to promote caterpillars?
Yes, so if you look at our list, the one you memorized, Maples are in the top 10, I'm almost sure. So they're particularly as you move further and further north where sugar maple takes over, they become very important in producing caterpillars. And not just the number of caterpillars, but the type of caterpillars they produce. They're really good at producing inchworms, geometrids, which are favorites for the migrating birds. They're not hairy, they taste good, and when they're there in numbers, our migrants do really well. And that's one of the big problems. When gypsy moth outbroke in the 70s, and we flew over and sprayed 7 on all the forest, I don't know if we killed the gypsy moth, but we sure killed those geometrids. And you know what? They have never bounced back. They've never been at the numbers that they used to be. So it's another reason that our birds have been suppressed. So maples are fine, absolutely. Not Norway maple. What's the difference? Norway maple has sticky latex sap, just like the milkweed. And our insects, our maple eaters, can't deal with that.
I've been told that the bat population has declined in the past year or so. And of course, the bats eat insects. Would you comment on those changes? It's true.
Oh, it's true. We have a disease called white nose disease brought over from Europe. And our bats, like the little brown bat, I don't have the latest figures, but they were down like 99%. I mean, just about gone. I think I heard that there are starting to be a few bats that are resistant, I hope, and they will rebuild the populations, but they have been clobbered by this disease that was brought over from Europe by spelunkers. So again, it's us, yeah. Introducing a disease that our bats are not able to handle. Do we have a bat expert here? Oh.
I'm not a bat expert, but I certainly am a bishop's weed expert. Other than how to get rid of them, do you have any thoughts other than moving?
Bishop's weed? Gout? Yeah. Early successional, right? We don't do that. So I don't have a lot of experience with it. I don't want to give you ignorance here. I think you have to move. I'm sorry, somebody up here will have know more about it, I'm sure.
Doug, thank you very much. That's